Arrays are great when all your data are homogeneous, but the world is full of data that's not homogeneous. Let's think about how to design a program for a simple contact list for your cell phone. We'll consider several possible options. Considering other options is an important step in the design process. Beginning programmers tend to use the first design that comes to mind. Instead of trying to create several designs, compare the advantages of each, and then decide which to implement. Each person has a name and a phone number. We could store our phone number as a string, even though that may not be the best idea. And then a contact list could be a string array. If you have 100 contacts, you'd need an array that holds at least 200 strings. This isn't a very natural way to store the data. Suppose we wanted to sort the data by name. We'd have to write some super special sorting algorithm just for this data, since we'd only want to use the even indices and would have to keep the adjacent data together. This is not going to be easy to write, and we won't be able to use the arrays.sort method that could do the work easily and perfectly. Another possible design would be to create two arrays. We could have an array of strings that holds the names and a second array of ints or strings that holds the phone numbers. This design is called a parallel array, and it has problems. We're relying on the indices of the arrays to remain synchronized, to know which name goes with which phone number. If we sort one array and don't update the other in exactly the same way, suddenly the link between the name and the phone number is lost, and the contact list is useless. We still couldn't use our arrays.sort algorithm with this, because even though it could sort the name array correctly, it wouldn't be able to keep the phone number array aligned. We need a way to group together names and phone numbers into a unit that can be put into an array. This is exactly what a class is. We've been using classes since the first week of the course. Every time we create a main program, we have to put in some class somewhere. And we've used lots of classes in the Java API, but up to now we haven't written meaningful classes on our own. What we need to do is to create a class that stores a name and a phone number. By including these two data elements in a single class, we're grouping them together. The objects of this class will have one reference that will be used to access both data elements. When we design classes, we use a standard notation called UML for Unified Modeling Language. UML has 12 different kinds of diagrams that are used to design object-oriented computer programs in many different languages. We're going to use only one kind of diagram, the UML class diagram. You'll learn the other diagrams as you need them, just not this semester. There's a neat plugin for Eclipse that will generate UML diagrams that we'll use, called Umlet. A UML class diagram is a box that's divided into 3 rectangles. The top box holds the name of the class. Class names always start with a capital letter and should be meaningful, so we'll call our class Contact. The middle box holds a description of the data elements that will be used to record the attributes of the class. In this case, our data will be called name and phone number. Name will be a string and phone number will be an int. The minus sign in front of the data means that the data is private. When data is private, it's used only inside the class. The lowest box contains a description of the methods that this class will have. These methods generally fall into 2 categories: accessors and mutators. Accessors give people who are using a class a way to find out the properties of the object. Mutators allow people outside of the class to change the stored data, but only if we decide their changes make sense. I've put in 4 methods that are generally useful: getName, getPhoneNumber, toString, and equals. You've seen toString and equals methods in lots of other classes, and these methods will do pretty much the same thing. The plus signs in front of the method names means that the methods are public. This means that people who use our class will be permitted to use these methods even though they're not permitted to directly access your data because it was private. I've also included a constructor in the lowest box. Now, to be honest, this isn't really standard UML, but I found that my students tend to forget to write constructors if we don't include them in the UML design. If you don't write a constructor for a class, Java will write one for you. Now, that may seem considerate, but the Java compiler doesn't really have a clue about what your class is supposed to do, so it can't write the constructor properly. This creates some serious debugging problems, and it's invisible to you. It's hard to debug something you can't see. Constructors are almost always public, so they get a plus in front of their names too. And remember that the constructor name always matches the name of the class, including capitalization. This constructor is taking a string for the phone number instead of an int, even though the data is stored as an int. I did this because it would be convenient to use a constructor with a string parameter outside of the class. The world outside of our class does not need to know how we choose to store our phone number internally. Now, if you still think that having the compiler write a constructor is a good idea, remember the constructor could never pull off converting the phone number from a string to an int without a programmer's help. Compilers just aren't that clever. You're allowed to have lots of constructors for classes. They just need to have different parameters so the compiler doesn't get confused about which one to call. The string class, for example, has a lot of constructors, even though we haven't used most of them. The pattern of having private data and public methods and constructors is a good place to start with any class. We'll encounter exceptions, but don't focus on them too much for now. Data is private so we can be sure that it's correct. Methods are public so that other people can use our class. We could create an object from this class using the constructor. We would say contact friend equals new contact, Jenny, 8675309. The memory diagram for this object will have one box for every data field. These boxes represent the attributes of the object. Each object in the class could have different values for the attributes. The memory diagram for the constructed object looks like this. Remember that name's a string, which is an object from the string class. Since objects are stored by reference, the contact object referenced by friend will store the reference of the string object. Every object in the same class will have the same attributes, but each attribute may have a different value. You can think of attributes as being the properties of the objects. So let's create another contact object. Contact sister equals new contact, Missy, 5551235. The sister object has the same attributes that the friend object we created earlier had, a name and a phone number. Each object has its own value for each attribute. The friend object's name is Jenny. The sister object's name is Missy. Here is a memory diagram that shows the sister object and its reference. You may wonder what the code looks like that implements this class. Well, here's some of it. I prefer to show the data at the top of the class. I usually put the constructors next, then the accessor methods, and then the mutator methods. Another possible way to organize the methods is by putting them in alphabetical order. It isn't so important that you do things exactly the way that I do them, as it is that you're consistent. If your data is at the bottom, it should always be at the bottom. If you work for a company, they'll probably have instructions about how they want these things done, so don't get too attached to your personal preferences. The constructor's job is to be sure that every data field has been perfectly initialized. This is tricky in this case because there are lots of things that could go wrong with a phone number. I've checked 3 of the obvious ones: 8 characters long, hyphen in the 4th position from the left, and made up of digits. There are other rules to phone numbers. For example, the 555 prefix is used to make fake phone numbers. They're a little too much for us now. Here's the code. Public class contact. Now, this is the data. Each object is going to get its own copy. Private string name. Private int phone number. The next thing we have is the Javadoc for the constructor. Notice it starts with a /**, uses an @param for each one of the parameters. Constructors don't have a return value, so you won't see @return in the Javadoc. Here's the constructor. Public contact, string my name, string my number, name equals my name. If my number length is not equal to 8, system error print line, improper format for the phone number equals -1, that indicates an error, and return, because we can't go any further if the phone number isn't correct. If mynumber.charat3 is not equal to a hyphen, then system error print line, improper format for phone number phone number equals -1, and return. Here's our last test. For int I is 0, I less than 8, plus plus I, if characters dot is digit of my number dot charAt of I, system error print line, improper format for phone number equals -1, return. What I did there is checked that every single digit of the phone number was in fact a number, not a letter. That's an important thing to check. The rest of the class will contain accessor methods and mutator methods. We'll do those a little bit later. We're initializing the data fields to values that come from the arguments via the parameters my name and my number. Notice that I didn't name the parameters for the constructor name and phone number, because then the parameters in the data fields would have the same name, which will confuse the compiler. There are other ways to work around this problem, but I think giving your parameters better names is the easiest way. The constructor and all the methods have Javadoc style comments. We can process Javadoc comments into cool web pages, just like the API in Eclipse. Just choose Generate Javadoc from the project menu in Eclipse. If your software is properly installed, you'll be able to see your documentation when you hover the cursor over the method calls. Now let's write the toString accessor method. This method is supposed to return a single string that summarizes all of the data in the object. Here's the Javadoc. This method will return a string representation of the contact object in the following form: name, phone number. @ returns a string representation of the contact object. That ends our Javadoc. Here's the method. Public string toString, return name plus plus phone number divided by 10,000 plus hyphen plus phone number mod 10,000. Remember, we use a %, but pronounce it mod. Most accessor methods are very simple, like this one was. The Javadoc is actually longer than the method. The shenanigans with dividing and modding by 10,000 are converting our integer to a string with the expected format. Now, mutator methods have the responsibility to make sure that the integrity of the data in the class is maintained. In this particular class, we don't have any mutators. This design is fairly common in classes. For example, the string class also doesn't have mutator methods. If someone wants to change a name or a phone number, they have to construct a new object. When we put these contact objects into the array, the name and the phone numbers are grouped together into a single unit. Now that we're able to create our own objects, we'll be able to keep our programs much better organized. We'll construct arrays of contacts just like we construct other arrays. Contact square brackets contact list equals new contact of 100. There is a difference, however, between constructing arrays of primitive data types and arrays of objects. When we construct an array of objects, all of the references are initially null. We have to construct the objects in addition to the array. This is usually done in a loop. Let's write some code that will create our contact list. Scanner input equals new scanner system in, contact square brackets contact list equals new contact of 100, int size equals 0, system out print line, enter a contact name or -1 to terminate the program, string name equals input.nextLine, while not name equals -1, system out print line, enter the phone number, string phone equals input.nextLine, contact new person equals new contact name comma phone, contact list of size equals new person, plus plus size. System out print line, enter a contact name or -1 to terminate the program, string name equals input.nextLine. Notice that I used a priming read there. Now that we have an array of contact objects, we can search and sort and do all sorts of wonderful things.